All right, hi everybody, and welcome back to our webinar, Applying the 7 Steps of Data Analysis to Produce a Quantitative Research Study. William Bannon of Stats Whisperer here again. Now, in this presentation, we will review Step 2, which is data entry, where we will learn how to enter data from the survey hard copies into an SPSS database for analysis. We will also learn, toward doing that, how to create an SPSS software database, how to code data and create a data dictionary, as well as the process of cleaning the data and recoding variables. So these are a lot of good marketable skills we'll be picking up today. Now, in the context of the 7 steps of data analysis, you are here in step 2, which is data entry. Now, I'd like to make just a couple of opening comments about data entry. Data entry is often seen as a more nominal part of a study, right? And in such, there's not a lot of instruction on doing data entry correctly. However, you see in point 3 here, and this is absolutely true, the entire study hinges upon data entry being done correctly, right? So put yourself in the context of the study. So you may write a research proposal and it gets funded. It's a great design, right? And it's collected properly, and you come in to enter the data, and if the data aren't put correctly from the survey hard copies into the SPSS database, well, then the whole study is for naught, right? You can't do the statistical analysis and get the right results if the actual data weren't entered correctly from the survey hard copies into the SPSS database, right? So really, this is a juncture where if it's not done correctly, the entire study is going to misrepresent, the findings and the sample and the study population. So this is a very important process. Now, data entry is more than data entry, right? So we could break data entry down into 3 main areas. First, there would be coding the data. Second, we could call entering the data. And third, we could call cleaning the data. Now, true to our Russian dolls, each of these steps has sub-steps, right? So coding the data is also going to include our creating a data dictionary, right? So we could see our codes and so on. Now, entering the data is going to include creating the software database and entering the survey data. Now, cleaning the data, as you can see, that has the most sub-areas, right? So that's rather involved. So cleaning the data might include referencing the survey hard copies against what's been entered into the database, examining the variables, looking for violations in logic, which will be explained, and recoding the variables. Now, coding the data, creating the data dictionary. Step 2, data entry. Here we go. Part 1, coding the data. Now, how can we code the data? So, as you see, the first step is we need to give each survey item a name for data entry. So the survey being, the hard copies of our survey that we administer. So we give it a name so we could enter that name in the SPSS software database. 2, we're going to give each response to each item a numeric code. And then 3, we're going to list the names and codes in a data dictionary so that we have them for reference. So what does that all mean? Well, suppose this is our study survey, right, on the right here. So you can see in the upper left-hand corner, we have ID, right? So we always give each study participant an ID number, right? So the first variable in the database and the first thing we note on the study survey is the study participant ID. And this one is number 1 because it's our first study participant. Now you'll notice this study survey is just a small truncated version of our entire study survey because it's just for teaching purposes. If you can code a few variables, you can pretty much code the whole survey. So we're just going to take a few for an example. So the first item is highest education level. So that's item 1. And then you can see the possible responses below, which are A, high school GED, B, college 4-year degree, and C, graduate school. Then our second item is personal income, last year, and that's answered in thousands, and the person would just put, the raw number, their personal income. The third item is, have you had a drink? So actually that's short, and it's actually, have you ever had a drink of alcohol? And the answer is yes, no. And then the final item is number of drinks last week. Now pay attention, this is what they call a skip pattern, right? So if they say, have you ever had a drink of alcohol? And the person says no, the study participant says no, there should be no response to the number of drinks last week. Because if you never had a drink of alcohol, you shouldn't have had any drinks last week. So again, that's called a skip pattern. Now, these are the names we've assigned to each of the survey items. So this on our right now turns from being the actual survey into being our version of the data dictionary, right? The data dictionary is where we're listing, our coding, which are the names of the items and our responses, right? So first we're giving each item a name, right? And this will be reflected in the SPSS database, right? So the key is try to keep the names to about 8 digits. It used to be in SPSS you couldn't make them more than 8 digits, but now you can make them pretty long. But keeping them around 8 digits will keep them short, but also identifiable. For example, we might call study participant ID just ID, and that's almost universal in every database, right? We haven't even assigned that red letters, it's just ID. So we have given red letters to highest level of education, which is survey item 1. So it's common to call highest level of education EDUC, EDUC, right? So that would be the name for survey item 1, EDUC. And then 2, personal income, we might just call income, right? And we've inserted a text box here right next to the item in Word, and we've made the letters red so we know that it's actually not part of the survey, it's part of our data dictionary coding. And then, have you ever had a drink of alcohol? We just call drink alc. And the number of drinks last week, we just call num drink, right? Now, the names can't have spaces in between them, so it's just one long name. If you put spaces, the SPSS database won't accept them. Right, now you'll see, also in red text, are numbers next to the possible responses for each survey item, right? So highest level of education, high school / GED now has a 1 to the left of it, college, four-year degree B, now has a 2 to the left of it, and graduate school, IMC, now has a 3 next to it. So what we're indicating in our coding is the survey item is named Educ, and the possible numeric responses now are 1, 2, 3. So if somebody circles high school GED in the SPSS database, they would get a 1. Okay? And then you'll see for personal income, item 2, we put raw number. So whatever they say we put. Number 3, drink alc. 1 is yes, 0 is no, and no is always 0. So we'll explain that later. But right, so 1 and no. So if the person says, have you ever had a drink? And they say yes, they get a 1. If they say no, they get a 0. And the number of drinks, again, is going to be the raw number they indicate. Now here's a note. If you recall our composite item measure for happiness, right? So we have 5 items that are going to be composited, meaning they're going to be combined to create one score reflecting happiness. So if you have a composite item measure, it's common to give the names a theme, so you realize they're all together, right? So they're related and they have an ordered format. So these 5 items are combined to measure happiness, right? So we might put Q1, feel happy. So you'll see each of them is numbered according to their order in the composite scale, Q1, Q2, Q3, right up to Q5, and it also starts with feel. So it looks like they're all together. It's like one measurement, and that's always convenient to do. So when you look at the database, you can see they cluster together. Now the special case of check all that apply. So you'll notice in some surveys, they'll have a question and it'll say, in parentheses, check all that apply. Right? In this case, when you have a check all that apply, you have to make each response a yes/no category. So it might be one item and it might say check all that apply to 5 little subcategories. So each of those subcategories has to be a yes/no variable because people can have all sorts of patterns in what they say yes or no to. For example, if we were looking at exposures to neighborhood violence or crime, right, we might have a check all that apply that looks like this, A, B, or C. Such as A, have you ever been mugged? Yes, no. B, robbed? Yes, no. Or C, chased? Yes, no. So the person, the study participant, may have experienced all 3, or none of these, or maybe A and C, or B and A, or B and C, right? So there's all different sorts of patterns. So each one is made into a yes/no variable, so they can indicate that pattern freely. Now, as I said before, yes is always 1, and no is always 0. And if you ask why, it's a good question. We'll explain it right now. So 3 exposures, mug, rob, and chased, okay? So if all the exposures, right, if yes is coded as 1 and no is coded as 2, right, and they've had all the exposures, right, so that means yes, 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 1, 1, 1, the score is 3. However, if no is coded as 2 and they've had no exposures, that's no, 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 but no is 2, that means it's 2 plus 2 plus 2, which equals 6. So in that case, if no is coded as 2, when they've had no exposures, they have a score of 6, and if they've had all exposures, they have a score of 3. So they have twice the score if they've had no exposures, which is not ideal. It's kind of misleading. So then it looks like people who had no exposure had twice the amount of exposure relative to people with all 3 exposures, which is even confusing to say. So The preferable thing is the last line where no is coded as 0. So if they've had no exposures, it's no, 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 which is 0, 0, 0, 0 plus 0 plus 0 plus 0, which equals 0. So total exposure would be 3, and no exposure would be 0. So it's always useful to keep no coded as 0. Now missing. So missing data are quite formidable, right? So whenever we get missing data, we have to have something to put in the cell. It's not appropriate just to leave it blank, right? So what we want to do is use extreme numbers, right? So they're not mistaken for valid responses. For example, if we were going to put in the number 9 for a missing item, right, a missing response, and its age, right, and we put in the number 9 for missing, we might think that the person's age is actually 9. So we can't tell the difference between somebody who's 9 years old and a missing data point for the variable age. So if we put 999, obviously we know they're not 999 years old, so we could see, oh, that's a missing data point, right? So we usually put in 777 when the item's just missing, right? So when you get a survey back and there's just no answer for that item, we put 777. 888 is what we put for refused. That's for, say, personal income. If somebody was asked what their personal income is and they didn't want to indicate that, that's fine. But we would put that as 888, refused. And then 999, not applicable. That would be put, for example, in our skip pattern, right? Remember we said that, have you ever had a drink of alcohol? Well, if the person says no, 0, the next item is number of drinks last week. Well, that should be not applicable because they should, right? That should not apply to them because they've never had a drink, so they couldn't have had any drinks last week. So there we would put 999. And again, it's unlikely that anybody would have had 999 drinks the week before, so that's also an extreme value that we know equals a missing response. All right, part 2, entering the data. Now here we're going to create our software database in SPSS. Then we're going to enter our survey item data into that database. Now, the first thing to keep in mind when we're creating our database is that in the lower left-hand corner of SPSS, currently, the current version, they have 2 tabs. One says Data View, and the other says Variable View. Now we're going to start in Variable View because that is where we create the variables, which is our first step. Now, while in Variable View, you'll notice that there's 11 columns, right? So 5 of these columns are what I call primary, right, that we need to focus upon because these are the 5 columns that you need to complete in order to do the SPSS database correctly. The first column is name, right? So that's where we give the name of the item, right? So we gave each item a name in the data dictionary, right? So that's the first column. Then type, right? And we're going to go through these right now. Then 3 label, 4 values, and 5 missing. So we'll go through each of those in detail. Now here we go. So this is what the variable view looks like in SPSS. Right? So the first column says name. So almost universally, the first name we put in is ID because that's for the study participant ID. And we'll look at this in actual SPSS in a moment. Right? Now recall, on our data dictionary, item 1, highest education level, was called educ, EDUC. So we put that right in there. Right? So the ID, then educ, and then we just go down the line, putting the names of the variables as per the data dictionary, right? Personal income, item 2 was income, and then 3, have you ever had a drink of alcohol, drink alc, and so on. So we've entered them all in the name column. Right? Next, we put the type of variable. Now we'll look at this too, but you'll notice we're putting numbers as responses for all the survey items so far. Right? So study participant ID, it's ID 1, it's ID 2, so they're numbers, so we put in type numeric. And then education, remember we made high school, GED 1, college, 4-year 2, right? So, and then graduate school was 3, so those are all numbers. So educ is also numeric, and income we're putting in raw numbers, so it's also numeric. And drink alc, have you ever had a drink of alcohol, is 1 and 0 for yes and no, so that's numeric also. Now, the other commonly used types are string, which you put in for text responses. So if a question is asked, it's an open-ended question, and the person can report actual, words, and you put in string, which are text responses, and then date also, such as what date was the survey taken. You could enter date, but 80 to 90 to sometimes 99% of all variables are numeric, typically. Unless it's a qualitative study, then it's probably the other way around. Label. Now label is just what the survey item is, right? So the ID is participant ID, right? Educ, we could put in education level, or if you prefer, you could put in the item from the survey. What is your highest level of education, right? You can cut and paste the survey items directly out of Word into SPSS if you prefer. Then income level, and then that's what we've done here for drink alc, right? Have you ever had a drink of alcohol? All right, next, values. So those are the actual responses to the items. Right, so we'll go into SPSS and enter it, but this is how it looks once it's entered. Right, so you can see educ, right? 1, the high school GED, that's entered. Right, so drink alc, that's 0 for no, 1 for yes. Now income, right? That's a raw number, so we don't have to enter any values for that because we're just entering the raw number reported for income. And the same with ID, we don't have to enter any values for that. It's just the raw number, what the ID is. Now missing items, that's what's put in to the 5th column, right? That's where we put our 777, 888, and 999, right? So when we put those in the column, SPSS now knows to treat those numbers as the missing responses, and it will not include those in some of the tallies of percentages, right? Because SPSS will know to treat these numbers differently because they're not valid responses, they're missing responses. Now, if we go back to that lower left-hand corner and we switch out of variable view and we click data view, this is what we'll see at the very top. You'll see the names of the variables we just created, right? So the variable names, ID, educ, income, drink alcohol, and below that, there will be blank cells where we can enter the data from the survey hard copies. For example, suppose this was a completed study survey we had to enter. You can see the person, ID 1, right? So study participant 1. They indicated their highest level of education was a high school GED, right? Item 2, their personal income was $58,000. Have you ever had a drink of alcohol? They circled yes for item 3. and the number of drinks last week, they also indicated 3. So you'll see when we go in the data view, we just ascribe, right, the responses to each item. So for ID, their ID is 1, so we put a 1. For item 1, highest level of education, they circled A, which if you remember our data dictionary was coded as 1. So in SPSS for EDUC, they get 1. For item 2, for income, they got $58,000, so we just put the raw number in there. And for drinking alcohol, it's a yes, so that's a 1, and number of drinks is a 3. Right? So it's pretty simple. So we can go in SPSS right now and actually enter those items. Right, so let's get our SPSS database here. Right, so we look at creating, right, so ID, right, there's ID, there's EDUC, there's income, there's drink alcohol, just like in our slides. Now the type of variable, so EDUC, for example, so it's numeric, but if they were going to enter their actual highest level of education, as in they were able to type their own words or write their own words into the survey hard copy, you click on this right here, this is how you choose the variable type. So it's numeric because it's 1, 2, or 3, but if we made it string, they could actually type in an actual word, right, and describe. So if it was a certification or what university did you go to, we could make it string, and they could write in their actual university as a response. Now, it's important to realize the characters up here in the upper right-hand corner, that's the number of letters they could type in as a response. So they can type no more than 8 by default. See, characters 8. So you could make that 100. So they could type up to 100 letters, or 200 to type up to 200 letters, right? And that's important because if you have a long response, you want to be able to enter the whole thing. And if you cut and paste it from Word into SPSS and the characters are truncated, it'll cut off part of the response, right? And then also date we mentioned. So there's date if we wanted to make it a date form, but we're going to keep it numeric. Right? And then label right here. Remember we said we could enter the survey item or just education level. So we could do that here. Right? And then values, right? So this is the possible responses, right? So you can see it's filled in for the rest, but not for education. So we click right here. So value labels, remember 1 was high school GED. And then we click add, and then 2 was college. And we click add, and 3 was graduate school. And we click add, and then we just click OK, and they're all in there, right? So it looks like the way it looked on the slide, right, where 1 is the beginning. And then the missing items, right, so we have to tell SPSS what are those special numbers that indicate it's a missing item and not an actual response. So here, it's at no discrete missing values, so we click discrete missing values, and remember we have 777, 888, and 999. You could also make it a range if you like, but we're going to keep it right here, and OK. Now the great thing is you can also cut and paste that, copy, and then paste it here. And so you don't have to keep typing in the same thing over and over. So now we have all our variable names created. So if we go down here and switch to data view, as we mentioned, right, there's study participant ID 1. So we go over here. We know their education level was high school GED, which corresponds to a 1, so we just put a 1. We know their income was 58,000, so we have our decimal at 2 spaces, so we just put 58 here. Drink alcohol, we know is a yes, so that becomes a 1. And the number of drinks they had last week was a 3, so we put a 3. And that's pretty much all there is to it for the primary duties in creating that database and entering the data. Now our next step, cleaning the data, right? So part 3, this could be very involved if there's a lot of cleaning to do. So hopefully the data will have been entered correctly and there won't be too many snags, as they say. But let's address how to address snags, right? So 1, referencing the hard copies. Let's look at that. Now referencing the hard copies is not complicated. However, it's very useful. So what does that mean? It means you actually just take the survey hard copy after the data has been entered, or have been entered rather. And so after the data have been entered, you just take the hard copy and you look at the data in the SPSS database, right? So if it says income is $100,000 for study participant 10, right, then you're going through their survey, their hard copy, and comparing it to the data in the database for them. So you're saying $100,000 for their personal income. You look at the hard copy, it says $100,000. And you just go item by item, checking it to make sure what's in the SPSS database is also actually what's on the survey hard copy. Many times, if one item is missed on the survey hard copy, all the numbers are off by 1 space, right? And it's pretty important to catch that. Now, you can imagine it could be time consuming if you have 100, 200 surveys and you're sitting there checking each one against the data in the database. So sometimes you'll just do 10% of the surveys. So if you take, every 10th survey and you check that hard copy against what's in the database, and it all seems pretty continuous, right? As in what's in the database is what's on the hard copy, you might feel pretty certain that the rest are following in suit. So that's always a good alternative if you don't have the time or resources to do every survey hard copy. Right. Next, examining the variables, right? So what we're looking for here are several items such as evidence of an invalid response, right? So that, for example, recall our happiness items, right? So if the range of responses is 1 to 5 and we discover there's a 6, that's an invalid response. And we want to make sure to catch that, right? Now, how can you do such a thing? You can run the frequencies, right? So frequencies is a often used tool in your SPSS database, right? So we're going to do it right now. So this is the path to doing the frequencies, but let's run it live. And let's check education level for an invalid response. So here's our SPSS. So we go to Analyze, and analyze the descriptive statistics and frequencies. We click that, right? So number of drinks last week we don't need now. So we take education level. We put it here, and then we could click paste, but we don't need to see this. We're just testing for invalid responses. So we click OK. Oh, and then we see here in the output, right? So we know 1 is high school GED, that's fine. 4 is college, 4-year, and graduate school. But here, so there's a response of 4. So this is 1, 2, 3, and there's a 4. We didn't code any of the responses as 4. And then we look at the frequency, how many times 4 was entered, and it's 1. So this tells us there's an invalid response, as in there's mostly valid responses, but one study participant has a 4 entered, which is not a valid response, right? So we need to go find that. So the thing to do is go reference the survey hard copy and see what that person gave as a response. Many times it could just be a typo. But before we do that, we have to find out where this 4 is. So if we go back to the survey, right? So let's go back to the SPSS database, and let's say drink out, no, income, no, edu, right? That's our variable where we know there's an invalid response. So we know the invalid response is a 4. So it's higher than all the valid responses. So one of the ways to find it is if you right click and you click sort descending, right? The 4 comes to the top. So in the education variable, that 4 is the invalid response. So suppose we went to the survey hard copy, and we saw that for study ID 5, right? ID 5, survey 5, was supposed to be a 3. So that was just a typo. So we just change it to 3, right? So now we go back to analyze and run our frequencies again. And we see now, right, everything's in order. High school, GED, college, and graduate school, there's no responses outside the valid responses. So that's how that's addressed. Now, our next item, item 3, are violations in logic. That's where one response conflicts with another response. So the first response makes the second response improbable or impossible, right? There's a conflict, such as our skip pattern we mentioned earlier. If we ask, have you ever had a drink of alcohol? And the person says no, but then in the next item, when it says, how many drinks did you have last week? And they say 3, well, one of those responses is not valid, right? So many times, if that's what's actually entered in the study survey, that would just result in missing data because you don't know which one is true or not. So let's go into SPSS right now, and we'll see how we can deal with this kind of conflict. So how can we find, for example, if somebody said they never had a drink, but then they report the number of drinks that they had the next week? Well, we can use what's called the data select function. Now, there's a few functions in SPSS that you use pretty regularly, and this is one. So data select, so we go to data, and then select cases. Then we go all the way to the top here and say if condition satisfied. Then we go to if, and let's actually replicate this and explain what we're doing. So we know, ever had a drink of alcohol? If they say no, that's coded as 0, right? So we want to put that up there and say drink alcohol equals 0. So what we're doing is we're selecting all the study participants who have reported that they never had a drink of alcohol. And then we say continue, and you could either paste this to save it in the syntax or click OK. Now we'll click OK here because we want to take a look at the hash marks. So you see these little hash marks here. Those indicate that the study participants will not be included in the analysis, right? So if we see drink alc 1 here, so they say yes, they had a drink of alcohol, they have a hash mark, meaning they're not included in the analysis, and all the way down the line. So the zeros that say they never had a drink of alcohol, they are included in the analysis. So if we run our frequencies on the number of drinks, they should all be 999, not applicable, right? Because the only people included are people that said they never had a drink, so there should be no number of drinks reported, right? So right here, it should all be 999. So if we go back to our frequencies and we put in number of drinks last week, and we say, okay, oh, look what we have. There's 45 that have 999. That's appropriate. So those 45 that said no, never had a drink, they also have 999, as in they didn't have any, it's not applicable how many drinks they had last week. But there's one, right? There's one person, frequency 1, where the person has 3. So one person, frequency 1, one person that said they never had a drink reported they had 3 drinks the week before. So if we go back into our database and we look, right, well, we can see right here, this is the person. And so let's say that we didn't see them that fast, right? Okay. So let's say everything looked in order, we don't see them really fast. How could we find that one person? Well, we could sort, right? Sort ascending number of drinks. And we know that there was a 3. The person who reported having 3 drinks and also reported never having a drink was a 3. So we could put our cursor right here on the 3. And we go down and we could keep an eye on drink alcohol next door. And we can see right here, there's the conflict. This is the person that indicated 0, never had a drink, but then indicated 3 drinks the week before. So we could go, of course, to the survey hard copy and check that person's responses. Was this 3 a typo, or did the person actually report this? And if they reported this, again, this might be coded as missing data because we don't know which one is true. Okay, so we can go back now, right, and talk about number 4, recoding the variables in SPSS. And this is a data cleaning / data preparation activity, right? So how do we know which items need to be recoded, right? For example, let's consider the item feel sad on our 5-item happiness instrument. Now, what's the problem here? The problem is that if we're trying to measure happiness, most of the items where we indicate a 5 indicate the highest level of happiness. So we say, are you happy? And they give a 5, strongly agree. Well, that's the highest level of happiness. But then the next item, if it says, are you sad? If they indicate a 5, strongly agree, that indicates the opposite, the lowest level of happiness. And then good, strong, and glad, 5s all indicate the highest level of happiness also. So we have to make it all continuous, where a response of 1 for sad, so are you sad, strongly disagree, that would indicate the highest level of happiness. So we have to reverse the 1 through 5 to 5 through 1, where people who indicate a 1 are going to get scored as the highest level of happiness. So that's called reverse coding items. So all the responses on all the items indicate the same construct, happiness. So if we go to SPSS again, and we want to look how to recode, right? So to recode, you go to transform, right? This is another one of these commonly used up. And don't forget, if you're doing some sort of selection, you want to take the selection off, right? So you go back to select cases, and you just click all cases. Then everybody's included again. So OK, and then we go back and look, and the hash marks are gone. So one big happy family again, everyone's included. OK, so we go to transform, then we want to recode into a different variable because we don't want to just change the existing variable. We want to create a new version of that variable reversed. So we click that, and then you can actually drag this out and expand it so you can see the variables better. Then we see feel sad right here, right? So there's the original feel sad. So we put that to the right. And now the first thing we do is under output variable, we have to give the new variable we're creating a name. So since it's feel sad reversed, we could just call it feel sad reversed. Right? Feel sad reversed, and then we click change. You can enter the label, the name if you want to now, or after it's done. Then after you have the name in under output variable, you create old and new values. Right? So old value, right? So since we're making 1 through 5, 5 through 1, the old value of 1 is now the new value of 5. And you click add. The old value of 2 is now the new value of 4. 403 just stays a 3. Now 4 will become a 2. And 5 will become a 1. So then you can even read it up and down. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, right? So it's reversed, right? So then we click continue. Now this is something you actually want to paste because, let's see, what if one of these was reversed, right? You did it incorrectly. What if you said a 1 becomes a 2 or a 2 becomes a 3, right? Well, you want to have a record of that you could go back to reference to make sure you did it correctly. So we could have clicked OK and it would have changed the variable, but we paste it now, right? And don't forget to save your syntax, right? Save as. So we paste it so we can keep a record. Now to run it, instead of OK, you just highlight it and click the big green arrow. And you'll see in the output, it'll say if it did it right, right? So it'll say you have to read the syntax like it's actual text. So feel sad, the original, is reversed where 1 is 5, 2 is 4, 3 is 3, right? All the way, and that's turned into feel sad reversed. And if you look at the database, at the end of it, there's feel sad reversed. It's been created, right? If you double click here, you see it right here at the end of the data view. Now, whenever you do that, you always want to compare the old and new variables to make sure the reversal was successful. So if we go to Analyze, Descriptive Statistics, and Frequencies, we take out number of drinks, we put in the original feel sad, and then we put in feel sad reversed. And so we have the original and the reversed. Click OK. And then you can see it started at 9, 25, 49, 11, and 6. And now it's reversed. 6, 11, 49, 25, and 9. So it was successful. So that's always great to see. All right. So next class, we're going to be getting into step 3 in the 7 steps of data analysis, checks of data integrity. Now there's 4 of them, but next class we'll address check 1, statistical power, and check 2, test assumptions. And in the context of our 7 steps, right there, step 3, checks of data integrity next week. Okay, thank you for watching, and I'll see you next week.